What's up, y'all? Today we're going to be talking about factoring and specifically factoring special cases. All right, so we'll have two cases that we will consider. All right, when we are factoring perfect squares. All right, that's when you'll see something generally in the form, and I'll give you the general form here of a squared plus 2ab plus b squared. That's going to factor down nicely to just be a plus b squared. All right, we can also see the negative of this, where we'll have a squared minus 2ab plus b squared, and that's going to factor nicely down to be a minus b squared. All right, so that's when we're dealing with perfect squares. Okay, we'll have something like that, and you can pause this and write it down if you need to. Okay. The other case that we're going to discuss is a difference, all right, of perfect squares. All right, when we start out, all right, with a squared minus b squared as our fully simplified standard form quadratic, all right, or polynomial, and we can factor that out to be a minus b times a plus b. Okay, in both of these cases with factoring, they are special cases because we can notice a pattern and do it more quickly. But, okay, and I'll emphasize that in this video, when we are actually factoring these, we're going to follow the same rules that we've followed before. Right? You don't actually have to identify these as special cases. They will factor out the same way. There's just a pattern that goes along with it that we can determine to do these problems a little bit more quickly. Okay. All right. We have 3 examples. Let's go over those. Once again, if you need to write down things, just pause this. All right. Write down what you need to and then continue from there. All right. Example 1. All right, if we're given the trinomial x squared plus 6x plus 9, and we're asked to factor that, this is actually one of those perfect squares, all right, because we have x that's squared, we have 2 times 3x, and then we have 3 squared on the end. So if you can notice that pattern quickly, all right, then you can easily factor this to just be x plus 3 squared. If you don't notice that pattern quickly, then that's okay. We'll draw our box for organization. Toss the 9 there, toss the x squared there. We know x and x is going to give us 9, x and x is going to give us x squared. And then we are looking for, in this case, it has to be the same number. So 2 numbers that multiply to 9, all right, that would add to 6, and it's going to actually be 3 and 3. It's going to be the same number, and that's a good thing. That's what we want. So we would have 3x there and 3x there and be able to factor out the positive 3, x plus 3, x plus 3 to give us x plus 3 squared. Okay. Cool, let's look at example 2. We'll do it a little bit more quickly. All right, in this case, we will have x squared minus 12x plus 36. All right, notice the pattern. You'll get that factors out quickly to be x minus 6 squared. If you don't notice the pattern, then we will factor it the same exact way we've done it before. All right, putting 36 there, x squared there. I know x and x will give me x squared, so I can always fill those in. Then I need 2 numbers that multiply to 36 and give us negative 12. Because we're notified that it's a special case, we know that they're going to be the same number. All right, negative 6 and negative 6 works for us, so we got negative 6x, 6, negative 6. So that's going to be x minus 6 times x minus 6, which then we are going to simplify to be x minus 6 squared. That's why we call it a perfect square, because it's one of those binomials raised to the second power. All right, third example, and this is our final one. Example number 3, all right, if we're given x squared minus 16, all right, if you notice that that's a difference of perfect squares, you can immediately jump to the x minus 4, x plus 4 factoring. If you don't, then let's actually consider rewriting it, all right? This x squared minus 16 is the same thing as x squared plus 0x minus 16, and then it looks exactly like every other factoring problem that we've done. Kind of break it down to be negative 16 here, x squared there, we got x and we got x. We need two numbers that multiply to give us negative 16, but also add to give us 0. All right, reminder that these special cases, we're going to use the same numbers, but in this case, they actually need to be opposite of each other because they need to add to be 0. So negative 16, all right, we're going to have positive 4 and negative 4. Those two added together is 0. Those two multiplied is negative 16. So I got negative 4x. I got positive 4x. So we got x plus 4, x minus 4, and this factors out to be x plus 4, x minus 4. Okay, so we can do this the same way we always have, but if you notice some trends, you can just kind of use a shortcut with them. All right, couple problems at the end. Good luck on those, and I hope to see you next time. Bye.